Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC B12F0, indicates a loss of communication between the power control unit and the electric steering lock in the Honda Odyssey, model years 2011 to 2017. This issue often hampers the ability to start the vehicle, as the electrical steering lock is a crucial component that secures the steering column when the vehicle is turned off. It acts as an anti-theft measure, ensuring that the steering mechanism is immobilized when necessary. The electric steering lock is typically located within the steering column area, which means access to it may require some disassembly of interior panels. Identifying this DTC allows for targeted diagnostics and repairs, ensuring the vehicle can be safely operated without the risk of theft or malfunction. The error associated with DTC B12F0 revolves around a missing communication signal between the power control unit and the electric steering lock. The electric steering lock is responsible for preventing the steering wheel from being turned when the vehicle is off, thereby enhancing security against theft. The power control unit, often referred to as the ECU, electronic control unit, manages various vehicle functions, including the steering system. This DTC indicates that the ECU cannot verify the operational status or send necessary signals to the electric steering lock. The location of the electric steering lock is within the steering column, making it crucial for technicians to access this area while diagnosing the issue. Effective troubleshooting begins with understanding the relationship between these components and their roles in the vehicle's electrical system. Potential causes for the DTC B12F0 include several factors that can disrupt communication between the power control unit and the electric steering lock. Loose connections in the wiring harness can lead to intermittent failures where the signal is inconsistent. A faulty electric steering lock itself may fail to respond or communicate properly with the ECU. Another common issue is a blown fuse, specifically the number C18 fuse rated at 7.5 amps. Located in the driver's underdash fuse box. An open circuit or high resistance in the wiring can also hinder proper function. Addressing these causes is critical to restoring communication and ensuring the electric steering lock operates as intended. Symptoms associated with DTC B12F0 include difficulties starting the engine, as the electric steering lock may prevent the keys from being recognized. When the steering lock engages, it will physically stop the steering wheel from turning, which can alarm drivers and lead to an assumption of a more severe mechanical failure. Drivers may also notice the presence of this error code when using diagnostic tools, which indicates an underlying communication issue between components. Additionally, if the vehicle appears to be unable to detect the key, this could be linked to the same fault. Detecting these symptoms early can prevent further complications and assist in prompt troubleshooting. A first step in troubleshooting the DTC B12F0 is to clear the diagnostic trouble codes using the Honda Diagnostic System, HDS. The HDS is an advanced diagnostic tool that enables technicians to reset fault codes and provides accurate information about various vehicle parameters. Clearing the DTCs is essential as it allows you to start the troubleshooting process anew and observe if the error reoccurs. Without clearing previous DTCs, any new tests may yield misleading results based on residual data. This proactive measure effectively refreshes the vehicle's electronic systems and can reveal if the fault was transient or indicative of a more serious problem. The second step requires cycling the engine start-stop button through different modes. First, ensure the button is pressed to select off, then ACC, accessory, followed by on, and once more back to off. Repeat this entire cycle 10 times in succession. This procedure is crucial as it helps to re-establish communication protocols within the vehicle's electrical network. By effectively cycling through these modes, the system can reset and potentially rectify temporary connection issues that may have led to the DTC being set in the first place. Ensure that each mode is fully engaged before transitioning to the next to let the system acclimatize properly. After completing the previous steps, the technician must check for active DTCs using the Honda Diagnostic System HDS again. This step is essential to verify whether DTC B12F0 has reappeared. If the DTC is still present, it indicates a persistent communication issue between the power control unit and the electric steering lock. However, if there are no DTCs indicated, it suggests that the earlier problem may have been intermittent or resolved. In such cases, further investigation should focus on inspecting for any underlying loose or poor connections that might reintroduce the fault. Analyzing the diagnostic data ensures that no issues remain unchecked. For the fourth troubleshooting step, measure the voltage at the electric steering lock 12P connector's terminal number 3, while referencing the 12P connector layout. This terminal is critical as it connects directly to the power supply. Identify the terminal by locating the wire side of the female terminals, specifically the red wire labeled SMART for battery voltage. If you observe battery voltage, this confirms that the power supply is intact. If no voltage is detected, the issue could point to a blown fuse or a fault in the wiring, requiring immediate attention to restore proper operation. It's critical to use a reliable multimeter for accurate measurements to diagnose effectively. In step 5, the next test involves measuring the voltage at the same electric steering lock 12P connector, but now focusing on terminal number 7. This terminal is connected to ground, identified by the black wire labeled GND. It is vital to ensure that this terminal has less than 0.2 volts. If this measurement is accurate, it indicates a good ground connection, critical for the effective operation of the electric steering lock and ECU. However, if higher voltage is measured, it signals poor ground connections or high resistance within the wiring harness. Addressing ground issues is fundamental because inadequate grounding can lead to various electrical malfunctions, including communication failures like DTC B12F0. The sixth troubleshooting step involves pressing the engine's start-stop button again to select the off mode. Selecting this mode prepares the vehicle's electrical systems for safe removal of the connectors without creating short circuits or additional faults. This preparation is vital, as unintended power when disconnecting components can lead to further damage or miscommunications in other parts of the vehicle's electronic systems. Following proper procedures ensures that the technician maintains safety and avoids further complications. Once in the off mode, technicians can proceed to safely disconnect the necessary connectors for further evaluation and repairs. After completing all necessary repairs and modifications based on previous tests, the final step involves reconnecting all previously disconnected connectors. It is essential to ensure that all connections are secured to avoid any further communication errors. Once reconnected, use the HDS to perform a final system functionality test to verify that there are no active DTCs and that the electric steering lock is communicating effectively with the power control unit. Observing normal operational parameters will confirm the success of the repairs. This step is critical, as it helps to affirm that all troubleshooting efforts have been fruitful and that the vehicle is safe for operation. To prevent future occurrences of DTC B12F0, regular preventive maintenance is essential. Technicians should routinely inspect all connectors associated with the electric steering lock and power control unit to ensure they are secured and free from corrosion or damage. Loose or corroded connectors can often lead to communication errors. Additionally, periodic checks on the health of fuses, especially the number C18 fuse, are vital in ensuring that there are no blown fuses that could lead to similar issues. Regular maintenance checks will help in preemptively catching potential failures, ultimately enhancing the long-term reliability of the vehicle's electrical system. In conclusion, dealing with DTC B12F0 requires a comprehensive understanding of the roles played by both the power control unit and the electric steering lock. Systematic diagnostics should be employed to ensure accurate troubleshooting, identifying all possible causes, such as loose connections, blown fuses, or faulty components. It is essential to approach the problem methodically, conducting each step with attention to detail while prioritizing safety throughout the process. Following preventive maintenance practices can significantly reduce the likelihood of future faults, ensuring the reliability of the vehicle's steering mechanisms. Properly addressing DTC B12F0 not only restores functionality, but also contributes to the overall safety and security of the Honda Odyssey. Please like and subscribe to the channel. See you next time.